Next up is DNS query filtering, and with that we are back on track. The times are as in the schedule again. There you go.
Hello, I'm Héja Péter, and I'm going to talk about DNS query filtering, or how to increase your performance and accidentally block users. So the problem we had was that we have an authoritative name server, which is actually two name servers. One is a recursive name server that's not our solution, and there is a solution that's ours, and it's written by us, but it has to be complemented with a real and feature-complete recursive DNS server. But because we are using a recursive server, that means we serve everything, and because we serve everything, that's a great UDP amplification vector. And the problem is that we had no time to fix it nicely, as we were notified by the provider, our cloud provider, that we either fix this or we are going to be blocked, and we don't like being blocked. So, possible solutions, fixing it nicely. This takes long, both on the side where we are fixing our custom solution, because it takes development time, a lot of it, or we could use a different recursive DNS server that allows us to filter which zones we serve, for example, ours and nothing else. Or we could use iptables rate limiting, which means we serve less junk, but we still serve it, and we serve less of our valid users. Or we could create content filtering, and that takes some development, and it would be nice, but we don't have time, so nope, iptables. So we are going to use string matching, to be specific, hex string matching, but this sounds very, very expensive in the kernel space, so we must perf test it. We did hex string filtering like this. If you want to filter events.cccde on UDP port 53, then you can do it like this, and this blocks it, or on TCP almost the same, but this is block listing, not whitelisting. We tried out hex string, and the overhead is very low. Our original setup could serve 60,000 queries per second from our zone, from one node obviously, and less than 5,000 queries per second recursive queries. So with hex string we could drop 240,000 queries per second of recursive queries, which is very nice, and it took only 1% CPU time, which is a great and low overhead solution. And we could still serve near the original 60,000 queries per second from our zone. But the problem is that we wrongly filter all TCP traffic, which is less than 0.1% of our traffic, and wrongly drop all OX20 queries, which is around 2%, a bit less. TCP filtering is not that easy if you think about it, because the streams can be fragmented, and you can string match packet by packet, and it's quite obvious. Although every guide tells you to do it like you do on UDP, but that only works because they block list, not whitelist. So it doesn't work for us. And on TCP, we don't have a UDP amplification vector, so why do it anyway? OX20 is a security feature, so if you encode random bits as lowercase, uppercase, then you can be kind of sure that you get a valid answer. Events.ccc becomes lowercase e, uppercase ve, lowercase n, uppercase t, lowercase s, and so on. We like memes, but not in our DNS queries. However, this is a quite easy problem, because you can solve it with case-insensitive matching, and it's not a problem anymore. In conclusion, it was fun to try it out, and I blocked to 3% of our users, which was less fun. Takeaway is that we must test more thoroughly if you introduce stricter iptables rules. You can do that by inserting it before the existing one, do some logging, whatever you want. Thank you for your attention, and major props to Max, my colleague, who recommended hex filter, and thanks to Vista from NOC, who helped me prepare.
Right, thank you. Then next up is writing drivers in high-level languages.